Hi, welcome to COM 2026. Today we're going to continue on the topic loop. We want to focus on how multiple loops can be used together to create more sophisticated logic. So if you haven't go through our for loop and while loop chapter, please watch the video. This is an example that will show how multiple loops can be used together. Let's look at this one. Assume the user input a value, which is the size of a rectangle. We're going to print out the size of a rectangle with the argument that user inputs. So what we're going to do is to write a program, probably using a loop. This is a very bad answer if we're not going to use a loop. Why? Well, as you can see, this solution simply try to eliminate all the possible values the user can input. Unfortunately, the user can input a lot of different integers from 1 to 100,000, which means in our code we need to spend a lot of space to produce these things, which is totally infeasible. Now, to solve this problem, we're going to ask ourselves how many rows that we need to print. Well, apparently, if the user input like 5, we will need to print 5 of them. If user input 7, we need to print 7 rows. Okay, so the number of rows really depends on what the number the user is inputting. Let's say this number is called size. So we're going to repeat it for size time. The second question is going to ask how many number of stars that we need to print on each row. Well, again, that will be size. Okay, so what we're going to do is to put number of size numbers of rows with size numbers of stars. Okay, the first intuition is to put this piece of code inside these bars. Well, let's try to do it. If we try to put these things inside these loop, we are setting up a nested loop. So instead of just directly copying that piece of code into the loop, we want to first make sure these variables are not duplicated. In a nested loop, each loop should have its own counters. So the variable I in the inner loop was renamed as j. And remember, the counter's name does not really matter. In particular, in this example, we're not using the values of j in the inner loop, or we're not using the value I in the outer loop. But we want to make sure the values I and j are distinct. The reason is very simple. If you are using the same value, whatever the values changed inside the inner loop will also affect the value outside, which will make your program entirely incorrect. Okay? So this setup will allow us to print, let's say we input 3 as the size, print 9 number of stars here, which is slightly incorrect. All right, we are almost there, but we miss a few enters. If we can stroke an enters here and here, that will be awesome. Okay, but how? So what we need to do is to hit and enter whenever we finish printing a row. This is the part that we print a row. So whenever we finish printing a row, we insert a blank enter by system.out.println. So that is the way that we create a n by n square. This is our first nested loop. Take a look again. We will need to have size rows of data And each of them, each row, we have how many of them? Size of answers to print out. Let's look at another example. Assume we want to produce these numbers. Okay. Now we know there are mathematical formulas for each of those. For example, for x, that will be 1 plus 100 multiplied by 50 divided by 2. Okay? Sorry, 1 plus 100 times 100 divided by 2. So 1 plus 100 times 50. That will be 5,050. Okay? Now for the rest of those, we also have a formula to calculate those things. But well, if you don't know those formulas, or like me, just remember the incorrect formula, why don't we just try to develop a programming way to solve these questions? So look at these. This solution basically declare how many numbers appear. Okay, and for x, we loop the value I from 1 to 100. For each time we add the value I into x. So this x is actually containing what? Containing the sum of I from 1 to 100. Okay? The first time I equals to 1, x equals 1. The second time I equals to 2, that x will equals to 1 plus 2. This one, very similar, but each time we are going to increment the value of I by 2. So I plus equals to 2, okay? And then y plus equals I. That we will have the value 1, 3, 5, 7, and so on. That will put it in y. Z, that we're taking the value of I times I for each time. W, we're doing very similar things. I hope you can understand this part. Now, none of that is a nested loop, okay? And this is much more difficult. That exclamation mark symbol here is called factorial, all right? So I factorial equals to 1 times 2 times 3 times up to the values I. Okay, for every I larger than 1, this is well defined. Even 0 factorial is also defined, but let's not deal with 0 first. Let's just deal with 1 factorial plus 2 factorial and up to 10 factorial. Factorial, let's say we want to compute them using a native way, using a loop, okay? And computing t is actually quite tricky. Fortunately, if I know the values of each I factorial, I can actually sum them up. Okay? And to compute I factorial is also feasible, because if I know the value of I can compute I factorial too. So look at this idea. Let's say if I know the values of I factorial, I can sum them up into t using this loop. Okay? Well, I factorial, we need to know what is it. And if I know the values of I, can I compute I factorial? Yes, I do. This part does provide us I factorial. Okay? I factorial begin with 1, and then we want to multiply that by 2, 3, and up to I, right? So j equals to 1, and then multiply that to I factorial, and then multiply the second values to this one up to the value of I. Okay, so this part will calculate as I factorial if we know what's the value of I. This part will calculate as the value of t if we know what's the value of I factorial for each I. Okay, so basically what we're going to do is to combine these two together. And how? Well, quite straightforward. So this is the outer loop, which compute the values ranging from 1 to 10. Okay, and each of them we can use the values of I declared in the outer loop to compute what's the values of I factorial. So if we know what's the value of I, let's say I equals to 1, we know what is the values of I factorial here. Okay? If we know what's the values of, let's say, I equals to 5, then we know what is 5 factorial using this code. Okay? So this example tells us that how do we compute 1 factorial, 2 factorial, 3 factorial, etc., etc. And so that we have 1 factorial to 10 factorial. Now this line system.out.println will serve the purpose to just to show you the intermediate result. You can take away this line if you don't want this. Okay, eventually we print out the value of t and which give us this. Okay, now this is another example of good use of nested loop. So if we take a deeper look at the nested loop this time, the range from I is from 1 to 10. The range for j will be a little tricky. It's from 1 to I. Okay, for each time j will be increment from 1 to the value I. And this I has to be determined before j. J relies on the values of I, so I has to be determined first. So look at the example here. When I equals to 1, the loop j actually is going to do for one time only. So it produced the I factorial equals to 1. When I equals to 2, okay, in the next loop, I equals to 2, j can equals to 1 and 2. Okay, so I factorial will equals to 1 times 2. When I equals to 3 in the next loop, j could equals to 1 and 2 and 3. Okay, so the I factorial we are calculating will be 1 times 2 times 3. Okay, let's try to trace this part. When I equals to 3, so assume I equals to 3 at this point, that actually changed this part of code into for j equals to 1, j less than or equals to 3, j plus plus. Now remember, j was starting to be 1 again when you just entered it in the loop. I factorial was reset to 1 at the beginning. So I factorial equals to 1 times 1, that will be 1. Okay? Now remember, this asterisk equals means to multiply itself by the values of j. Okay? That means I factorial equals to I factorial times j. Okay? So now for the first round, we're going to calculate that when j equals to 1, I equals to 3, I factorial equals to 1. In the next loop, next iteration of the inner loop, j becomes 2. 2 times 1, that becomes 2. And assign this 2 into I factorial. Then j becomes 3. 3 is still less than or equals to 3. So okay, we're going to execute the loop body again. That becomes 3 times 2, that will be 6. And 6 will be assigned to the I factorial. So we print the values of I factorial, that will be 6. So I factorial equals to 6 after this one. And then we put this 6 into the sum of t. Okay? Remember, t will accumulate the values of I factorial using this syntax. Now, if you have time, please try to click on this link, which will prompt you to our code, and you can try to understand by looking at it, running it, and maybe try to modify some numbers. So theoretically speaking, you can have many layers of loop. Okay, and you have to make sure that you need them all, because the number of iterations are multiplying, which means the number of operations is growing via multiplications. Okay, that will be eventually, if you have too many layers of loops, you will store your program, and it runs for a long time. Each layers should have different variable names when you have different variables. So here we can see the example. Now, there's no particular meaning for this loop, okay? It's only mixing several variables together, all right? And we can mix different for loops and the while loops and mix it together. They are totally fine, okay? But for each of the loops, if you are using a counter, make sure those variables are independent and those counter are not the same. So in the outer loop, we use I as our layer and J here and K inside the inner loop. Now after this J loop has finished, J is already finished its purpose. We can reuse J in another loop which is parallel to the J loop. Okay, this J is not visible outside this for. So here, where the pointer I'm pointing at, it is not using the value J. And that's why this J value can be reused here. Of course, we can replace the J here by K. So making it say K, 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 as K is not being used in the in the middle layers as well. So you can definitely use J or K here, okay, to reuse your variable names. Next, we want to talk about break and continue. So break and continue inside next loop uh, make an effect on immediate parents only. Okay. Now, so look at this funny example. We have I and J and K. And when K is less than J, we say continue. If K is larger than I plus J, we say break. Otherwise, we will just leave asterisk there. Okay, so for the first time, I and J and K has the values of 0, 0, 0. K is this condition or this condition does not always print star. And then when and then we loop the inner loop, so K equals to 1. Okay, 1 is not less than J, so we keep going. But K1 is larger than 0 plus 0, so this is fulfilling. And we say break. And we break it. When we break this loop, when we say break, it breaks the K loop. When it breaks the K loop, it means that it goes to the next iteration of the J loop. Okay, it goes to the remaining code of the J loop, which has nothing. So we increment the value of J by 1, and so J equals to 1. And then when J equals to 1, we come back to the K loop again. So K becomes 0 again. Okay, the break does not really reset K, but after you quit this K loop, okay, you go back to the J loop and it re-enter this K loop. So the value of K has been reset by this int K equals 0. Okay, remember this is the initial expression will be execute once whenever you enter the loop. Enter the loop, okay? So the values of K will equal to 0, and then we check the continue. Now, what's interesting here is when this continue, it continue running the K loop. So the values of K from 0, it goes to 1, okay? And then it goes to 2. And then you break the K loop. That will make your J be increment from 1 added to 2. But when J equals to 2, the middle loop will end, okay, because 2 is not less than 2 anymore, so this will go away and we will move the idle and so on. Now I would suggest you to take a closer look to this example to fully understand what this break and continue works. Okay, what breaks and continue works in this example is always have an effect on K loops only. But this never, please never be confused that this continue is to continue I or continue on the J loop. No, they're not. They're just continue on K. This break is always breaking the cables. So after these, we have really covered the while loop, do while loop, for loop, enhance the for loop, break, continue, and finally we have talked about our nested loop. I hope these will serve you a very basic concept about loops. We shall do some more practice in our lectures and labs to further enhance your understanding. Shall you have any problem, please feel free to ask us on Piazza or ask write in the comment of the YouTube. We'll try to answer that for you. I shall see you next time. Goodbye.